In today's episode of Color Me Flared, we are going to discuss the profession of nuclear engineering, which is one of the top 10 highest paid careers. Who is nuclear engineer? A nuclear engineer studies and creates the procedures, tools, and equipment needed to utilize nuclear energy and radiation. Many of these engineers use radioactive materials for commercial and medicinal purposes, such as in tools for medical diagnosis and therapy. Each nuclear engineer has a unique personality. They frequently have investigative personalities, which entails that they are thoughtful, reflective, and inquisitive. They are meticulous, analytical, logical, rational, and inquiring. Some of them are also realistic, which means they are self-sufficient, steadfast, sincere, pragmatic, and frugal. What do they study? Nuclear engineering is the area of engineering that applies the concepts of nuclear physics to other subatomic processes, such as the fission or fusion of atomic nuclei, or to the application of other nuclear processes. It specifically encompasses the design, interaction, and maintenance of systems and components like reactors, power plants, or armament in the subfield of nuclear fission, the study of ionizing radiation, nuclear safety, heat thermodynamics transport, nuclear fuel, or other related technologies such as the problems of nuclear proliferation, are also included in this field. What do they do exactly? The typical actions of a nuclear engineer are as follows. Create a nuclear machinery, including reactor cores, radiation protection, or related instrumentation. Watch over the functioning of nuclear facilities to spot any unsafe design, construction, or operating procedures. Analyze nuclear disasters and collect information that can be utilized to create preventative measures, create operational guidelines for processing and disposing of nuclear waste or for operating nuclear plants. Direct the operation or upkeep of nuclear power facilities that are already in operation to verify that they adhere to safety regulations. Test methods for utilizing nuclear material, recovering nuclear fuel, and disposing of nuclear waste through trials to determine its acceptability. Take corrective action, or, in emergency situations, order plant shutdowns. Additionally, positron emission tomography PET scanners and other medical imaging technology are being developed by nuclear engineers. Additionally, they might create or construct cyclotrons, which generate a high-energy beam used in the medical field to cure cancerous tumors. Most nuclear engineers spend their days in offices. However, the environment in which they work differs depending on the industry they work in. For instance, those working in electricity generation and supply do so in power plants, medical physics, and nuclear medicine. A significant area of nuclear medicine is medical physics, which has as its subfields nuclear medicine, radiation treatment, health physics, and diagnostic imaging. The majority of modern medicine's diagnostic capacity is provided by highly specialized and delicately working equipment, such as X-ray machines, MRI and PET scanners, and many more instruments that also reveal subtle therapy alternatives. Nuclear materials, nuclear fuels, and irradiation-induced alteration of nuclear materials are the two core topics of nuclear materials research. For nuclear reactors to operate more efficiently, nuclear fuels must be improved. Studies of the impacts of irradiation can be used for a variety of things, such as examining structural modifications to reactor parts and the nanomodification of metals utilizing ion beams or particle accelerators. Radiation monitoring and protection. The science and practice of radiation protection, also known as radiological protection, and concerned with shielding people and the environment from the detrimental effects of uncontrolled radiation, are fundamentally based on radiation measurement. These areas include detector design, fabrication, and analysis, measurements of fundamental atomic and nuclear parameters, and radiation imaging systems, among others. Nuclear engineers and radiological scientists are interested in developing more sophisticated ionizing radiation measurement and detection systems. and using these advancements to improve imaging technologies. Which universities or institutes offer this program? Technology Institute of Massachusetts, Georgia Institute of Technology, University of Michigan Ann Arbor, the University of Illinois at Urbana-Champaign, the University of Texas at Austin. How much do they earn? As of October 27, 2022, the average nuclear engineer's income in the U.S. is $246,472. The usual salary range for our most in-depth and nuclear engineer positions is $75,020 to $417,924. Don't forget to check these amazing products given in the description box below, no matter if you are an entrepreneur, a student, or an employee.
To find out more about different universities and institutions around the world, which career path to choose, and how entrepreneurs are doing in the field you want to enter, click to the subscribe button below and turn on that notification bell to get notified as soon as Color Me Flared uploads something new and exciting for you.